Welcome. In this lesson, we will discuss preparation of alkanols, specifically preparation of ethanol. Mainly, there are two ways in which ethanol can be prepared. It can be prepared in the lab, or it can be done industrially. So, under lab preparation, mainly we have two ways. One is hydrolysis of ethene. The other one is fermentation. So, if we begin with the hydrolysis of ethene, the reagent required is 1 ethene, 2 water. Condition required is concentrated sulfuric 6 acid, which acts as a catalyst. The other one is heat. Now the product form, that is the final product, is ethanol and concentrated sulfuric 6 acid. Now how does the reaction occurs? The reaction occurs in two steps. The first step, it will be ethene, that is C2 H4 gas reacts with concentrated sulfur 6 acid, that is H2SO4 liquid there. Therefore, this one now gives ethyl hydrogen sulfate, that is C2 H5HSO4. Now, how does this reaction occurs? Ethene first is compressed at a pressure of 30 atmospheres, and then it's absorbed in concentrated sulfuric 6 acid at a temperature of 80 degrees Celsius, forming ethyl hydrogen sulfate. So the second step, so that's the first step. The second step now is the ethyl hydrogen sulfate formed, that is C2 H5 HSO4 liquid reacts with water, that is H2O. This is where hydrolysis process occurs, and therefore this condition the condition here required is a source of heat there. So how does this reaction occurs? So this one now, it will form a product of ethanol, that is C2H5OH there, so which is liquid, plus sulfuric acid, that is concentrated sulfuric 6 acid. So that's how the reaction occurs. Now these two are miscible liquids. Therefore, if you want to obtain now ethanol, then a careful distillation is done, because the two liquids have different but close boiling points. So this is how the setup looks like. So you see ethene is compressed at a pressure of 30 atm, and then it is dissolved in concentrated sulfuric 6 acid, and then from there now it is dissolved in boiled distilled water, which will give ethanol. And now the second method is fermentation. Fermentation is the decomposition of an organic substance by microorganisms to produce alcohol, that is ethanol, carbon dioxide, and heat. Now, reagent used in fermentation of process is glucose. Glucose can be obtained from sugarcane or from grapes. Now, condition required is yeast, because the yeast contains enzyme zymase, and the other condition is a temperature of about 7 degrees Celsius. This is the optimum temperature for the enzyme zymase. Now, the product, the final product, is ethanol and carbon dioxide. Now, this is how the reaction occurs. You have glucose, which is C6 H12 O6. This is aqueous. Then here you have yeast, which contains zymase enzyme. And then here you have a temperature of 7 degrees Celsius. Therefore, this one now gives you ethanol, which is C2 H5OH liquid. And then you have carbon dioxide there, gas. So to balance that equation, carbon here is 6, carbon here is 2, 1 here, so here you place 2, so that becomes 4, and then here you place 2. So that equation is balanced. Now this carbon dioxide obtained is tested chemically using lime water. It will form a white precipitate with lime water, that's calcium hydroxide, for a short while. Generally, fermentation takes about 2 to 3 days at a temperature of about 7 degrees Celsius. So this is how the setup looks like. fermentation process. So you see glucose solution there and the yeast. So the role of the water, it acts as airlock. That is to allow carbon dioxide gas to escape. As well, it keeps out airborne bacteria. Now the resulting mixture is then distilled to obtain a distillate of ethanol, which is about 95% ethanol. So that is how fermentation process is done. The other method now, it can be done by industrially. So the reagent required is ethene, steam. Then condition required is a temperature of 300 degrees Celsius and a pressure of 60 atmospheres. Now, the other condition is a catalyst, which is phosphoric 5 acid. So this is how the reaction occurs. So you have ethene, which is C2H4 gas. So this one now reacts with the steam, that is H2O status gas. And therefore here the condition is a catalyst, which is phosphoric 5 acid, that is H3PO4, which acts as a catalyst. And then here you have a temperature of 300 degrees Celsius and a pressure of 60 atm. So this one now will give you ethanol. It will give you ethanol, that is C2H5 aqueous here, gives you ethanol. So that's how preparation of ethanol is done. Now next is physical properties of ethanol. Absolute ethanol, it's colorless, it is volatile liquid at room temperature, it has a characteristic smell, and it's also miscible in water. Now, general physical properties of alkanols. One, we look at solubility. Two, we look at melting and boiling point. And then finally, we look at density. Generally, alkanols are soluble in water, but insoluble in organic solvent. This is because alkanols are polar compounds, hence form hydrogen bond with water molecule. The trend solubility of alkanols in water decreases as the number of carbon atoms increase. This is due to increase in molecular mass. That is to say, ethanol is more soluble in water than butanol, because ethanol has a lower molecular mass than butanol. Melting and boiling point, generally they have high melting and boiling point. This is due to strong hydrogen bond. When compared to the corresponding alkanes, they show higher melting and boiling point than corresponding alkanes, because alkanols contain strong hydrogen bond, while alkanes, they have weak van der Waals forces. Now, how is the trend? Melting and boiling point increases with increase in the number of carbon atoms. This is due to increase in the strength of hydrogen bond. That is to say, propanol has higher melting and boiling point than methanol, because the molecular mass of propanol is larger than that of methanol, hence is held by strong hydrogen bond. Density, generally density increases with the increase in the number of carbon atoms. This is due to increase in molecular mass. Yes, that's the end of our lesson. Next we look at chemical properties of alkanols and uses. Thank you.